Right, so on this one, we're going to practice adding two vectors, and um, both of these vectors are at angles, and it's really important as we continue on here that we do well with this. Um, and so, yeah, again, when we draw this out, 22 meters, 15 degrees north of west. West is where we start, north is where we go, and then 68 degrees south of west. Looks something like this, just a general picture. Go 15 degrees north of west. Here's north. Go 15 degrees up. Got that. And then the next one is 68 degrees south of west, down like that. And the resultant is going to be something like that. So again, what we got to do, right, is we break up into our x and y components. Here's the first vector, 15 degrees north of west, 22 meters. So the y is going to be positive 5.69. The x is going to be negative 21.25. Go ahead and do this for the second vector on a coordinate axis. Get your total x, total y, and then once you get your total x, total y, you can bring them together in a final picture to get the resultant displacement. So go ahead and pause the clip and do that, and when you're ready to check, you can hit play to continue. All right, so the second vector should be negative 17.2 and negative 42.65. We'll get our total x, negative 21.25 plus negative 17.23 for a total of negative 38.48. And then our total y, positive 5.69 plus negative 42.65. And then we get our resultant to the left, 38 down 36.96. Should get a resultant of 53.36 meters, 43 degrees south of west, or this would be, what would that be? 46.2, I believe, west of south. All right, now with forces, it's important to remember that weight is another, and then capital W is force of gravity. Just have the preference of writing force of gravity. Really, is weight is force of gravity. With forces, there's many different kinds: tension, friction, normal force, and we'll be working through that. With Hooke's law, it's important to remember with Hooke's law, you got the force of gravity down, the spring force is going up, and the spring force itself is negative kx, which you need to memorize Hooke's law, where force is proportional to displacement. So if you double the displacement of an object with a spring, you should have double the force. And we're going to try the sample problem here. We've got, we can go ahead and draw our mass. Let's use a different color here. Draw our mass on the spring, and it goes down 3 centimeters, right? So down here, we've got our mass, and force of gravity straight down, spring force straight up. Some of the forces in the y equals ma in the y, right? So we got the positive spring force plus the negative force of gravity equals 0. And so therefore, the spring force should equal the force of gravity. And we'll bring this over. Spring force, and then should equal force of gravity. So yeah, go ahead and calculate that out. What is the spring constant for this mass? And then when you're ready to check, you can hit play to continue. All right, so we should get 16.33 newtons per meter. Remember the displacement here. The displacement is downward, so the displacement is negative. And so therefore, when we calculate force here, we have the negatives canceling each other out. And the force is therefore positive, and that should make sense. The force of the spring is upwards. Yeah, we got that there. Remember, with elastic potential energy, we calculate potential energy 1/2 kx squared for the spring energy. And let's go ahead and calculate that out for our spring here. It's displaced 6 centimeters. What is the elastic potential energy? So go ahead and pause the clip, and yeah, when you're ready to check, you can hit play to continue. Okay, so we should get 0.063 joules, 1/2 kx squared for, and then our units must work out, right? So newtons per meter, and then this got to be in meters, so we convert our 6 centimeters to meters. We should be good. All right, remember with Newton's first law, an object at rest will want to stay at rest as long as there's no net force, and then an object in motion will want to stay in motion as long as there's no net force. And when no net force, or when no force is acting on a body, that body will either remain at rest or continue to move along a straight line with a constant speed. So let's go ahead and try this one here with a chandelier. We can draw a free body diagram here. Force gravity straight down, force A up at an angle, and then force B over. And yeah, we can get some of the forces, set up some of the forces and figure out, the what's going on. We've got, remember force A in the X, F A Y. Our goal is to figure out what the tension force is for FA and for FB. So yeah, let's just go ahead and get this established as we get started. Some of the forces in the X, right? So MA in the X, positive X, positive Y, negative Y down here. So positive FB plus negative FAX equals 0. Acceleration should be 0 in a static situation. So FB should equal FAX. But the problem is we don't know either of these, right? We don't know FB and we don't know really anything about FA yet. So let's look at our Y, some of the forces in the Y equals MA in the Y, positive FAY plus negative force of gravity equals 0. So we add that over. Force applied in the Y, or force A in the Y, tension, should equal the weight. And yeah, so once you figure that out, you should be able to, well, figure, this out. You can figure out what's going on with FA, and then you can come into FB. So go ahead and pause the clip and finish this up, and when you're ready to check, you can hit play to continue. All right, so we should get for FA should come out as 2,263 newtons, and FB should come out as 1,131 newtons. All right, how about for this one? We have a light that's being hung with two angles. Let's go ahead and picture this here. We have FA holding up, on this side at 29 degrees. Same angle, alternate interior here, up here and then down here. 38 degrees over here, and we want to find out what FA and FB are. We have the force gravity straight down there, and so yeah, we can set up some of the forces. And the X equals MA in the X. We have our positive FBX plus negative FAX equals 0. And then there's some of the forces in the Y equals MA in the Y. Positive FBY plus negative, positive FAY plus negative force of gravity equals 0. Now, we got a problem here. We have, this is unknown, this is unknown, this is unknown, this is unknown. We have 4 unknowns. So that's an issue, right? We only have 2 equations that we can use for these 4 unknowns. So if you remember, what we have to do is get this in terms of trig. So FBX really is FB times something, right? Because we can get this in terms of trig. So if we set up a triangle and we set this up here, FB is the hypotenuse, H. I was doing this in the trigonometric color here, H. FBX is the adjacent side. So cosine equals adjacent over the hypotenuse. So really, we have cosine of 38 rather, is equal to the adjacent side over the hypotenuse, which is FB. So really what the adjacent side is FB times cosine of 38. And that is what we're going to want in here, FB times cosine 38, and that will take care of FB. So we're going to need to do the same thing with FAX over here. Set up a triangle, that's the hypotenuse, that's the adjacent side. Get that. Same thing over here, this is going to be FBY, so this is the opposite side, and that's the hypotenuse. So we need to get it all in terms of trig. Once we have it all in terms of trig, then all our unknowns is just FB and FA, and that's it. And then we can substitute, bring in our stuff into here and go from there. So go ahead and pause the clip and give this a try, and when you're ready to check, you can hit play to continue. All right, so we should have FBX, which is FB times cosine 38 plus negative FA times cosine 29. And then for the y, we should have FA times sine of 29, FB times sine of 38, plus negative force of gravity equals 0. And when we substitute, I just substituted over here. I just isolated this for FB times these values, placing an N for FA here. And then, yeah, then we have FB, which is cosine of 38 over cosine of 29 times sine of 29, plus FB times sine of 38. And yeah, then we can add those together. Again, algebraically here, what you can do is just do cosine of 38 divided by 29, and then take that number and multiply it by sine of 29. These are just numbers here, the trig functions. So FB should come out as 3,724. FA should come out as 3,355.